Now, when you try to melt the filler material or braze alloy, there is a requirement of the heat source. So, what are the typical heat source practically used for the brazing purposes? So, based on that we can define the different brazing techniques. One is that torch brazing. So, in this case the fuel gas flame is basically used, like acetylene, hydrogen or propane, they are used to heat the alloy material, brazed alloy. So, what are the typical application? So, when there is a tube can be try to use a fitting into the other components using the copper or silver brazing filler metals, we can find out this. We can generally use the torch as a oxy-fuel torch, basically the fuel torch in this case as a source of the heat, and that can be easily controlled locally to a specified zone, simply the focusing the torch in that specific position. Induction brazing is the another kind of techniques, induction brazing, where the induction means we generally use the electric coils to heat the part and as well as the brazing the filler material. So, in this case when there is a assembly between the tube to tube assembly, brazing can be done with the copper and silver alloy between these two tubes to join the tubes. So, induction heating, then here the electric coils is used. So, in this case probably it is more controlled way, we can produce the amount of the heat or we can control the temperature of the filler material as compared to the simply torch brazing process. So, other brazing process is the use a continuous furnace. So, there is a sequence of the torch preheating through preheating the sequence of the sample to get to assemble the different components through the brazing techniques. In this case sometimes continuous furnace are used. So, here the terms basically used in the preheating of the material, then heating and after that post heating zones. So, that can be controlled using the continuous furnace and with the sequential way. And of course, definitely the brazed alloy in this case also reach the melting point temperature and then solidify during the welding process. So, in this case silver and copper based brazing filler metals. So, silver and copper based alloy basically used for most of this assembly by this brazing techniques. Other type of brazing techniques is the basically vacuum furnace. We use the vacuum furnace also for the brazing process. So, in this case a furnace with the electrically heated elements which is basically part of the furnace and it generally occurs under the vacuum. So, what happens in this case also, of course, in this case the flow and the flowability of the liquid brazed alloy and capillary attraction are also achieved in when you try to do even the vacuum furnaces. The brazing alloy. So, why sometimes the vacuum furnace, definitely this process will be costly as compared to the other brazing techniques, but if there is a requirement of the or there is a application of the certain materials which is having very much sensitive to the oxidation. So, in that case oxidation, and that oxidation normally increases with respect to the temperature. So, in that type of material or to avoid this kind of to avoid the oxidation of the material, probably there is a need for the vacuum furnace techniques to get the successfully assembly for the different components using this type of brazing techniques. So, what happens, the pumping system actually removes the oxygen from the workpiece, from the focus zone where the workpiece is generally kept, and of course, in this case also we find out the application of the gold, copper, nickel, cobalt, titanium and the ceramic based filler materials are basically the vacuum brazed. So, if we consider with respect to all these different brazing techniques, the most simple application of the brazing techniques is the torch brazing. Rather, induction brazing is the more controlled approach, where we can control the temperature. Then continuous furnace and vacuum furnace are also other brazing techniques. So, in this case the continuous furnace it is open to air. But in this case we typically follow the sequence, the preheating, heating and the post heating zones are these three zones are basically controlled using the continuous furnace. Vacuum furnace is a simple way to taking the advantage of the contamination of the during the process. To avoid this contamination contamination with surrounding atmosphere, in this case generally the vacuum furnace are required. So, apart from this various brazing techniques, now we come back to that different soldering process. So, first we start with the principle of the soldering process. So, principle of the soldering process more or less is similar to the brazing process, but there is some minute difference with respect to the brazing process, that in this case the filler metal used in case of the soldering process must have the melting point temperature below 450 degrees centigrade. So, that means that filler metals may be different as compared to the brazing techniques. Flux normally applied to the fairing surface and then surface are basically heated. So, solder is added to the joint and then distributes between the closely fitted surfaces. So, in the similar principle the solder materials is basically distributed through the surface, and when the application of the heat to the filler material in this case also, and that basically melts and it is weighted the surface to the solid surfaces. So, in that principle the soldering process basically works. But main significant difference with respect to the brazing process is the strength of the solder joint is basically much lesser than the weld joint and even also less than that of the braze joint. So, in that case, but of course, the application or the applicability of the soldering process are different as compared to the brazing process. So, from the figure if you see that it is better explain the soldering process. So, lead from the component that there is a solder wire is used and copper pad on the board and circuit board, so basically to electrical heating, and the tip of the soldering iron, and in this case purposes was to melt the solder wire and that becomes the part of the workpiece material that is supposed to join with respect to other processes. So, and in practically we see in the electrical circuit boards there is a huge application of the soldering process. So, where the electrical connectivity may be the main important components, but may not the mechanical strength may not be the significant in this case. So, applicability of the soldering process is developed based on the connectivity of easy connectivity of the different component of the materials, maybe either similar combination or the dissimilar combination, but where the electrical connectivity is the main significant, but mechanical strength may not be significant in this case. Based on the applicability of the soldering process in general view, we can find out also some advantages and limitation of the soldering process. If you see that soldering process is basically low temperature heat source is required in this case, not that heat source is not required to melting the base material, or that means heat source can be applied, a low intensity heat source can be applied exactly on the soldering wire, where it is supposed to melt the soldering wire, not supposed to melt the base material. Parts can be disassembled after joining, the parts can be disassembled at any time by simply applying the heat. So, that heat actually not affect much to the base material. So, disassemble is also possible in this case easily, and dissimilar materials can be joined easily, for example, aluminum to brass and copper to steel. So, that means these dissimilar combination metals can be joined using the soldering process, but we cannot expect the much strength of this joint when we try to compare with respect to the normal fusion welding process or solid state welding process, or this joint strength even less than that of the brazing processes as well. So, typical limitation of soldering process is the strength is very low and it may damage under high temperature conditions. So, we try to localize the amount of the heat of the application, and of course, the heat intensity of the heat should be low enough, so that temperature should be controlled below the 450 degrees centigrade. Careful removal of the flux residual sometimes, because it is required sometimes in order to prevent the corrosion of the soldered surface. Large scale cannot be joined. So, basically mainly the soldering purpose in sometimes we use the repairing purpose. So, large sections probably cannot be joined, and very small components can be joined, and mostly for the repair purpose. And of course, the main if we look into the environmental aspects, the fluxes sometimes may contain the toxic components. Sometimes the flux contains the lead, which is not in which is the toxic components and may not favor for the as a green manufacturing technology. So, in that sense we try to avoid using that such kind of fluxes. So, apart from this, several advantage and limitation of soldering process, but still there is some development of the soldering process also happens. So, now if you try to look into this process, we can try to first look into what are the soldering tools. So, typical soldering tools in this process are soldering iron, fluxes, solder wire or stick, and spelter are also used in this process. So, soldering iron is basically consists of the copper bit attached to a iron rod and at one end, and other case it is attached to the wooden handle, so that it can be hold on. Then use it to melt this can be used to melt the filler material, and basically at the same time it can be used to paste that filler material to make the joint. So, that is the basic principle, and we have seen this soldering process in practically is applicable. Practically we can see this soldering process and very frequently in the connectivity of the electrical circuit board. So, most of the solder metals are of the alloy of tin and lead. So, basically percentage of lead is kept constant because it is toxic properties, and nowadays some other solder metals has been developed also to avoid of using the component like lead in this case. A solder is selected on the basis of its melting point definitely, and the melting point is relatively in the lower side, typically less than the 450 degree centigrade. But solder of the high melting point provides, if compare the high melting point, use the high melting point, but limitation is up to 450 degree centigrade. So, in that case it can provide the better strength of the weld joint. Tin promotes the weighting action required for making the joint. Basically, the purpose of using the tin, the melting point temperature is low, and it is basically create with nicely that weighting action when you try to join the two components of the materials. So, types of solders. Here basically two types of solders we generally observe. One is the soft soldering, another is the hard soldering. Soft soldering means used for joining the small intricate parts having low melting point, that is called the soft soldering. So, melting point is low. Tin lead alloy as filler material can be used, and of course, melting point of this filler material is below the 400 degree centigrade, around 400 degree centigrade. And then in this case, to locally melt that filler material, we generally use the gas torch as a source of the heat. So, typical characteristic of the soft soldering in general, we can say that operation is done basically the temperature in the lower side, temperature below the 400 degree centigrade. And accordingly we can use the different filler material, we can choose the different filler material and to melt the filler metal we can use the heat source, so that it can be locally applied even and should not affect much to the base metal, or that means temperatures, maximum temperature of the system can be below the 400 degree centigrade. But in the other side, that is the hard soldering, and sometimes it is also called the brazing process as well. So, definitely in this case hard soldering, or we can say the brazing process. So, in this case joints of the two metals can be used and relatively at higher temperature. So, filler metal used in such a way that their melting point should be the above 450 degree centigrade. So, it consists of the two components, one is the silver soldering. So, silver alloy can be used for the soldering purposes, and used for the for silver soldering used for the most non-ferrous metals and alloy, joining most non-ferrous metals and alloy, and other component is the simply straightforward the brazing. So, in this case brazing is defined in such a sense the in terms of temperature as well as the what are the filler materials is used for the brazing purposes. So, normally soft soldering is basically what we can call the in general, that is the soldering, and hard soldering we can say in general, that is the part of the brazing process. So, now we look into the what are the different soldering techniques. So, definitely there are several techniques exist depending upon the type of the heat source and depending upon the use of the different kind of filler materials, or based on the different methods. So, if we look into the different soldering techniques, we can find out that touch soldering, furnace soldering, resistance soldering, deep soldering, infrared soldering. All these are methods are common to the basically both soldering and brazing processes, but typically if we try to look into that, what are the different soldering process, what are the different methods of the soldering. First is the hand soldering. So, hand soldering basically small joints can be done in a very short time period, and typically hand soldering means it is done manually and using the soldering iron, and this method is mainly used for the repairing purpose, since it is done only manually. Wave soldering, it is also when there is a requirement of the large scale soldering process. So, in that case the wave soldering is the another soldering techniques where electronic components in the printed circuit board are joined, but in this case using these techniques we generally do the only electrically assembly of the different components. Typically the metal circuit board to the metallic components are done using this kind of soldering process. So, that means the large scale soldering process and the small scale soldering process, the difference is that small scale done manually and repairing purpose, but large scale soldering done when there is a when you try to automate this process, and there is a in this automation there is a need of the large scale welding process, large scale soldering process. So, there is another large scale soldering process, that is called reflow soldering. It is also widely used in the electronics industry to make the printed circuit boards, but difference from the wave soldering and the reflow soldering is that in this case the reflow soldering actually use the solid paste solder power and flux used, and they are applied to the spots on through the different spots on the board, and then board is heated to melt the solder, and finally it makes the forming the bond, the electrical bond as well as the mechanical bond between the two components. So, reflow soldering, in this process the importance is not only the electrical connectivity, the mechanical strength and electrical connectivity both are achieved in a very organized way. That is in that sense the reflow soldering is basically different from the wave soldering process.